Problems on the midterm. So the first one is a population versus a sample. You are going to population is part of the group and sample is the whole group. Sorry, I was checking something there. So on this one, we're looking, population is going to have the word like all in it. Okay, so population is all the households in the city, and sample is a group of 300 randomly selected. So when you randomly select someone, you're usually doing a sample. The average and a parameter goes with statistic. I'll go ahead and just screenshot this. We'll write some stuff out. I do have a video up on the webpage of my review that I did last week in the other class. That's going to be very, very similar, but I will upload this one as well so you have both. All right, so the sample goes along with a statistic. That is a real number that we actually found, whereas in a parameter, it goes along with the population, P and P. It's more of a prediction. What would happen if we did ask everybody, okay? So if it's talking about a population, it's a parameter. If it's talking about a sample, it's a statistic. So the average of 3.8 persons per household of the group of randomly selected households. So the key word there is the group of randomly selected households. That means it is a statistic. It is part of a sample, okay? 79% of all. So since it says all, that is a parameter. The 45% median family of the income of all the households. So that's talking about the population, okay? Those are talking about the population. So anytime you see the word all, looking at the population. I'll fix that later. All right, number 2. So on this one, I believe this is on your test work page, so you do need to show your work on the test work page. There is a trick on this one a little bit, but it says frequency. So there are 25 total in your counting there. It says what is the probability that you want, or find the proportion of waiting time sample that are at least 18 minutes. So at least 18 would be this one and this one, right? At least is always greater than or equal to. So greater than or equal to 18. So this would be 2 plus 2 is 4. So that means there's 4 people that waited 20 or at least 18 minutes. So I do 4 divided by 25, and I get 16%, or 16, the proportion of 16, because you do what you're looking at divided by the total amount. So all I really want to see on your test work page is something like this right here. Like that's on your test work page, just something like that. I mean, you technically could put all of this right here. You are welcome to use that page to work out on the back. Like use the back of scratch paper as well. You're welcome to put more than what I need to see, but all I really want to see is that right there. One thing I will note about this problem is if it says relative frequency, the chart shows proportions already. I'll just put, so you do not have to divide. If it says relative frequency, these numbers are going to be like 0.15, 0.20, 0.20, right? So they're already proportions. I just add them up or subtract them, and I don't have to divide. On this one right here, specifically, it would be like 0.08 and 0.08. So we would just add those up and get our answer of 0.116. So if they're already decimals, I do not have to divide, okay? If it is not a decimal, then I'm going to have to divide. So be careful on that one. That is what I'm saying, that it will give you like different variations of the test. That is why I tell you to do the review multiple times. All right, making a frequency chart. This is a little easier for me because I get to cross them off with my pencil here. But test scores, histogram. So you're just putting the right one in there. So between 65 and 71. 65 and 71 would be that one. Is that the only one? Oh, yeah. There's another 69, isn't there? Okay, that wasn't very good counting by me. Between 71 and 77, so 1, 2, 3, 4, 5. Between 78 and 83. 1, 2. Just those two. And then between 84 and 89. 2, 3, 4, 5, 6, 7. Okay, one thing that I would always do real quick, I know this is yellow and it's hard to see, is add these up. 9, 11, 18. Does that match? Yes, 18. Okay, that make sure you get them all because I know you all can't draw on your screen, but you want to make sure that you add those all up. Okay, make sure you have the right number. So then you just come over here and it's 4, and you don't want to miss one. By the way, when you take the test, 5. Finish this real quick, then I'll say that. When you take the test, you will be allowed to review the ones you missed. If you missed something like you just forgot a number or something like that, I can give you partial credit. Alex gives you partial credits when you have multiple parts and you just miss one. But if you think you deserve partial credit on one, I can give you partial credit. But you have to tell me to go back and look at your answers. And I'll mention this on Wednesday as well. You got to go say, hey, I think I could get partial credit on number 6 or whatever. You can email me or tell me after the test. That's fine. The problem, I don't go look at it because, honestly, it loads a little slow. So it would take forever for me to go through each one individually. All right, this one, it says the mean age is 31 and the range is 21. So the least variability here, that is talking about the ranges. So the least one would be 16. So it would be Team D. And then, based on the information above, which oldest has the oldest members on average? That is the mean. The oldest members on average would be this one right here. 38 is bigger, so that would be C. Okay? So this one is just telling you that you know the word variability has to do with range and the word average has to do with the mean. This one is on our test work page. I'm going to go over to the test work page real quick because on this one you just write, you just have the answers here. This is something you could write as soon as you get the test work page just as a reference, and this will help you just like on the problem we just did. But the measures of center have to do with the mean and the median. Okay, y'all can write that down right there. And the measures of spread have to do with the range and the IQR. The range and the IQR, okay? So measures of center are the mean, median, and mode. Measures of spread are the range, standard deviation, IQR, but for this problem, you only need those 4. So that's just identifying which one is which kind of helps you do the problem. So a lot of these test work pages, I try to do that to where I help you do the work the problem. All right, which one? Select the best description for the center of the data. Where'd my pencil go? So the center has to do with the mean and the median. So it's going to be one of those. We see a typical fish weighed about 22 or 23 by looking at the mean and the median. I like that answer. The next one says something about 46. That doesn't have anything to do with 46. Oh, they caught 46. So N equals 46. But that doesn't have anything to do. And that we caught 46 fish, so that's how many total fish we had. Typical fish weighed about 6 to 9 between the IQR and the range. That doesn't even make sense, but yeah. And then the spread, we are going to look at the range and the IQR. We can tell by the median the difference between the largest and the smallest is 22. No, because the median is the middle number, not the difference. We can tell by the number of fish caught that the difference between the largest and smallest is 46. No, 46 is how many fish we caught. We can tell by the range that the difference between the largest and smallest is 9. I like that one because that's my range. Largest and smallest is max minus min is the range. And then for this one, I will say that this one is a little tricky because for it to be symmetric on this problem, we can double check this. The mean has to equal the median. Okay? I know they're close. I know that the mean is 23 and the median is 22. But for it to be perfectly symmetric, they have to equal each other. Okay? If they do not equal, it is not symmetric. 23 does not equal 22, so it is not symmetric. So for this problem, they have to be exactly equal for them to be symmetric, and that does happen on this one. Let's check it real quick to make sure. Yes. It's because it does not say approximately symmetric. This one is on our test work page as well. Last year, over 7,000 students took an entrance exam at a certain state university. Rachel's score was in the 64th percentile, and Sam's score was the 27th percentile. Which of the following must be true? Let's answer the question, then we'll go to the test work page. Which of the following must be true about Rachel and Sam's score? They both scored higher than the median. Well, I know the median is the middle number, right? The median is the 50th percentile. So if Rachel scored in the 64th and Sam scored in the 27th, they are not both higher than the median. One is higher and one than lower. So it's not both higher, it's not both lower. Rachel scored higher than Sam. That is true. We do know that for a fact. We don't know what their scores are. Like, we do not know. They both could have failed the test. But we just know that Rachel's further along because 64% of people scored lower than Rachel and only 27 scored lower than Sam. Which of the following must be true about Rachel's score? About 64 of students who took the exam scored lower than Rachel. That is true. Rachel got 64% of the questions correct. No, a percentile has nothing to do with how much you got right. I'm sorry, I shouldn't say that. What percentage you got right. Rachel's score was in the bottom half. No, because she got 64. 64 is greater than 50. Rachel missed 36 questions. No, it does not tell you anything about your score. All right. For the test work page, there are two ways to look at a percentile. I say you can pick either one of those. We already have Rachel's right here. So 64%. Actually, we'll do. Nah, that's fine. 64% of the. Nope. %64 of the students scored lower than Rachel. That is true. Okay, and we kind of get that answer in part B. The opposite is all true. If 64% scored lower than her, that means what? 100 minus 64 is 36, right? 36% of students, 36% of the students scored higher than Rachel. So when you talk about percentile, you are talking about the position of the data. It tells you where it falls. So her test score, I do not know if she passed. I do not know if everybody passed. I have no idea, okay? It does not mean she got a 64%. It just means 64% of the people scored lower than her. Everybody could have got an A on the test, but 64% of the students scored lower than her, okay? That means 36 scored higher. So if 64% scored lower, that means 36 scored higher. And that's all I want to see on the work page is for you to interpret that two different ways using the same one. So I know that one should be lower, one should be higher, and they should add up to be 100%. Number 7 is also on the test work page. On number 7, again, this is something that can kind of help you do the test. You are welcome to write it down as soon as you get your paper. I'll give you a blank one of those papers. I know this is our first test I guess we've taken, but I will give you a blank one of those papers when you come in on Wednesday. So you can actually use this and study with it and all that. The 5 numbers and their percentiles of a box plot. So the 5 numbers are minimum, first quartile, median, third quartile, and maximum. Their percentiles are the 0. If you had the lowest test score, then 0 people score lower than you, right? 25th. Median is halfway. Third quartile, 3/4, 25th, and 100th. This is just kind of how it helps me to remember these. The 5 numbers, 0, 25, 50, 75, 100. If you have the highest test score, 100% of students score lower than you, right? And then it says define the IQR in your own words. IQR, so you could write, I don't care what you write on this one, it's your own words. But the IQR is Q3 minus Q1. It is the middle 50%. On your box here, I'm kind of skipping over to the problem for just a second. But this is your minimum, this is your maximum. This is your first quartile, this is your third quartile, and this is your median. So the IQR is how far it is from Q3 to Q1. So what I think about is the middle 50%. I think about it's how wide the box is, right? Because it's how far it is from here to here, Q3 minus Q1. So any of those things would work on that one. You don't have to write all of them, just anything that helps you remember what the interquartile range is. So this is all test work page stuff. But all this will help you answer the problem. All right, what is the heaviest weight? The heaviest weight would be my maximum. Right, so my maximum would be 41. What is the median weight? The median is the line inside of the box. That is 28. And what is the first quartile weight? That looks like it is a 23. Number 8. I believe this is the one that got cut off on your page. Didn't I tell you to write 268? All right, so I have the answer right here so you can see it. If you got cut off the line there, it says positive. This says as x increases, y also increases. If x is increasing and y is also increasing, that creates a upward graph. That is going to make a positive, right? As this one's going up, this one's also going up. That creates that shape. If it's negative, as x increases and y is decreasing, that's going to make it go down from left to right. So that's just recognizing that and positive is always increase, and negative is always increase, decrease. So as we work this problem right here, for these 21 students, as the number of hours increase, that is my x. The amount of money we spend also tends to, well, first of all, is this positive or negative by looking at it? From left to right, it's going up, so it is positive, so they should be the same. As x increases, y increases. For these 21 students, there is y'all just answered that, positive correlation. Using the line of best fit, we would predict a student working 10 hours. So we can use this line to predict and get our numbers from there. Let's see. 10 hours right here would go to the line, not the dot, the line. would be about 25. Okay. So we use the line as a prediction marker. Number 9. Oh, man, it's doing that weird thing. Why does it do that? Okay, I think I fixed it. Number 9 is how the sample correlation coefficient works with the R value. So let's go through each one first, and then we'll go back and answer the question. This one right here is a perfect downward negative line. They would say a perfect negative correlation. This would be R equals -1. Okay. R, as it goes towards 1 or -1, it gets straighter and straighter. It gets stronger and stronger. So this is a perfect negative correlation because it is in a straight line. That is -1. On this one, when I draw my line like this, it's obviously positive, right? It's obviously positive. I would say it's pretty strong. So we could say it's something like R equals 0.8, maybe something like that. It's going to be strong and it's going to be positive. It's going to be pretty close to 1. Working down right here. This one does have a downward track to it, right? So I would say maybe you could say like moderate negative. It's not as strong as this one. Like that one, they're closer together, right? This one, they're a little more spread out. So maybe this one's like, I don't know, -0.65 or something like that. It is negative. You can clearly tell it's negative, but they're not as close together as these are together. And then the last one, I cannot tell if that's positive or negative. There is no pattern there. So I would say this one is about 0. If it's towards 0, you cannot tell. All right. So to actually do this, it says, which data set has an apparent negative but not perfect? That to me looks like M and N because the other negative is perfect. Which data set has R closest to 0? That's going to be W and T. You cannot tell whether that goes positive or negative, so it's going to be close to 0. Which one has the strongest positive? That's going to be U and V. There's only one that we have that's positive, so it's got to be that one. And which data set has a correlation coefficient R equal to -1? That is going to be X and Y. Okay. I will say this about different variations of this problem. Here we actually used all 4 of them. Sometimes you do not. If you remember doing this problem, sometimes you do the same one twice. Or one of the answers is none. Okay. So you do not always use all 4. You may only use 3 of them. One of them may be none, or you may use one of them twice. That is possible on this one. Okay? Oh, no, let me do this real quick. Let me go back here real quick. No, I didn't. I do have to. All right, I think I got everything I need right there. Sorry, I know it's a little smaller when I go vertical. Okay, on this one, this is the difference between observed and predicted. Observed, when it says observed, that is an actual number we saw. Actual number, a true data point. Like, it is a statistic that we have. So if I go to 3.9, that would be this one right here. So my answer is 8.7. If I look at this graph, that is actually this point right here. That would be 3.9 and 8.7. So we actually saw someone do a gas score of 3.9 and sleep 8.7 hours. Okay. When we move to the next one, it says what is the predicted for 3.9. This one we are going to use our regression line. Okay, so if we were coming up here, we'd say 3.9. 3.9 is like right here. It's going to be this point on my line. On average, it should be about a little over 7. Now, we want the exact number, so what we're going to actually do is go plug it in to our actual equation up here at the top of the screen. Where's my calculator? So we are going to do 0.32 times 3.9 and 8.67. So our prediction is actually 7.422. It says round it to 1 or more decimal places. Okay. So that person that scored a 3.9 got 8.7 hours of sleep. That would be a lot more than what we would predict. Okay. So the prediction, we use our line. The line is the average of those points. That's just the average. The observed is an actual number we got. This is one just because I had someone email me from my other class. Like, this one is hard for me to give you partial credit on because if you switch them up, then I'm thinking you didn't know the difference between observed and predicted. I may give you a couple points back, but there's no way for me to really tell. But I will always try to give you some partial credit back. All right, on this one, how many we got, 15? An experiment involves 31 participants. From these, a group of 5 participants is to be tested under a special condition. How many groups of 5 participants are possible? When you have a total amount and you're choosing a certain amount out of that, it is permutation and combination. These buttons right here. You use permutation when the order matters, and you use combination when the order does not matter. This one says nothing about order, so I'm going to do 31 combination 5. 1, 6, 9, 9, 1, 1. For part B, from a collection of 50 store customers, 2 are to be chosen to receive a special gift. How many groups of 2? Doesn't look like the order matters on that one either. Maybe. Man, I wanted to leave that. All right, let me screenshot it real quick just to make sure if you go back and look at it, you'll know what we did. So this one was 31 combination 5, and this one was 50 combination 2. There's my buttons on the calculator. So again, you use your mate. So mine are both permutation. They may, when you take the test, they may both be permutation. I'm sorry, mine are both combination. When you take the test, they may both be permutation. They could be one of each too. So if the order matters, like if it's a password, or if it's first place, second place, third place, or president, vice president, travel's the weird one. You use permutation when the order matters. If the order does not matter, you use combination. A probability one right here. I don't believe. Oh, this has to do with the complement. This one's not hard at all, or shouldn't be. Don't miss easy ones. Melissa is a quality control inspector, work at a factory that produces inexpensive, unassembled furniture. She has a batch of 1,000, and she inspects those. 172 of these will not pass inspection. So the probability of A, that they do not pass inspection, would be 172 out of 1,000. It says write your answer as a decimal, so that would be 0.172. Okay. Probability B, that they do pass. Okay. Well, if I have 172 that don't pass and I have 1,000 total, I can subtract those. And get what would that be? 828. So this would be 828 out of 1,000, which would be 0.828. You are welcome to also do 1 minus 0.172 is 0.828. So this is having to do with the complement. If 70% of them don't pass, that means 83% of them do pass. Number 13, a deck of cards. All right, suppose a card is drawn at random from a standard deck, and then it is shuffled back in the deck. Then for a second time, it's drawn at random from the deck. What's the probability of drawing a 10 and then a black card? Okay, so for the 10, there are 4 of them, right? So that is 4 out of 52. If I put it back into the deck, then I am not changing my total amount. My total amount is going to stay at 52, right? If I took it out, then I'd have 1 less card, so it'd be 51. So a black card would be all of these. That would be 26. And then I multiply these numbers together and get my answer. That is 4 times 26 divided by 52 divided by 52 is 0.03636. Okay. So when you replace it back in, you do not change your total number. If you were not going to replace it back in, then you would do 52 cards or 51 cards or 50 cards. This one is one that messes with people. Conditional probability. So what is the probability that they do not play a sport? Hey, first of all, let me do this real quick. I like to do this. I'm going to add these up so we have the numbers here. 47, 23, 35, and 35. Now I have the totals for all of them, so now it's easy. Okay, so what's the probability that they do not play a sport? The probability that they do not play a sport would be, well, that would just be 35, right? I got 35 people out of 70 that do not play a sport. Just write it as a decimal, I guess. Okay. What's the probability that they're male and do not play a sport? Male and do not play a sport would be just these 28. Everybody with me so far? So this is 28 out of 70 is 0.4. All right, now this is the conditional probability. The conditional probability says male given, that's what this means right here, is given they don't play a sport. What you need to do is focus on the no sport. My no sport right here is, this is the only thing I am looking at. I do not care about anything else besides this column right here. So what is the probability that I get a male out of those no sports? So a male out of the people that just in this column would be 28 out of 35. Okay. When it says given, or that second one after that, male given that they are no sport, I already know that they don't play a sport. Like, that's the condition. I'm only looking at the people that don't play a sport. So if I'm only looking at the people that don't play a sport, I'm only looking at that column. So whatever the second part of this one is, that is the only column or the only row that I look at. Okay? Just to do another one of these, just to make sure we got it. What if I said the probability, let's say another example here. So if you go back and look at it, the probability that they play a sport given that they are female. If I say given that they are female, okay, if I say given that they are female, the only thing I'm looking at is that row right there. That is the only thing that I'm looking at. So given that they play a sport would be 16 out of the 23 females. Does that make sense? The probability that they play a sport, given that they are female, means that all I am looking at is the female row. I am ignoring everything else besides the female row. So now the sports out of the female row. Got it? Always look at the second one. So here, sports given female means I'm only looking at the female rower. Here, male given no sport means I'm only looking at the no sports row. Whatever the second one is, you only look at that row or column. And the last one here is a binomial one. So binomial can be tricky. The way to do this in the calculator. Kind of want. Hold on one second. I want to write my answer before I take a screenshot. Oh, no, that took away my answer, didn't it? Oh. Sorry, I just want this to be, if you go back and look at it, look at it the right way. What's the probability? Okay, here we did not have a chance to talk about binomial in class. Hopefully you watched the video or something. But the way that I look at this is I would say there are suppose that 45% of all babies born in a particular hospital are girls. If 6 babies born in the hospital are randomly selected, what's probably at least 2 of them are girls? I have 6 options here. 6 is my total number of trials. All 6 could be girls. The 5 out of the 6 could be girls. 4 out of the 6 could be girls. This is all my possible options. So if I randomly pick 6, 0 of them could be girls or 1 of them could be girls. There's options. I want to know what is the probability that at least 2 of them. So at least 2. At least 2 would be 2 or more, right? That's at least 2. That would be greater than or equal to 2. Whatever way you want to say it. That is what I am looking for. The problem with this is that my binomial button in the calculator is less than or equal to, and I cannot figure out what it is. I cannot change that, okay? It is less than or equal to, and I am not allowed to change that. So what I'm going to do in the calculator is I am going to go in the calculator, and I am going to figure out what if it's 1 or less, okay? What if it's 1 or less? Oh, man. So we do this and we get like 16%. If this is all my possibilities. So if this is about 16% for 1 or less, then what's this have to be? By just using some basic math here. Anybody? Last problem. 84, right? Yeah. So if this is 16%, this has to be 84%, okay? So I am not allowed to change in the calculator the less than or equal to. But what I can do, I'm not allowed to change it to greater than or equal to. But what I can do is figure out the left side of that what part's not circled and then do 100% minus that, or 1 minus the decimal, and that flips it for me. So if I want to try to flip this sign, what I have to do in the calculator is 1 minus, and that flips the sign. Does that make any sense at all? So what I can do is find the left side and then do 1 minus, and that flips it and gives me my answer to the right side. Okay? We'll do another one of these in just a second. So what I'm going to put in the calculator is I put the n, which is 6, the probability, which is 0.45. I'm going to find the left side, so I'm finding 1 to the end there, and then I do 1 minus, which flips it and gives me what I want. Does that make sense? This is a concept that we will use throughout the class quite a bit. When you can't change the sign in the calculator, you flip it. So just let me go over here real quick, and we can go over some more. Where's my sheet at? Right there. So here's like the different scenarios that you run into, okay? I suppose all of these are possible on the test. These 4 different scenarios. So here I have 8 trials. My probability is 65. If it says, what's the probability we get 5 or less? Well, I want 5 or less. So I want 5, 4, 3, 2, 1, or 0. Okay? So I am going to, I just put that in the calculator because the sign is less than or equal to. So it is 8, probability is 0.65. I want less than or equal to 5. That's the easy one because you just put it right in the calculator, right? If it said less than 5, what I'm actually looking for is 4 or less. Less than or equal to 4, right? So I put a 4 into the calculator. Does that make sense? This is why I'm always going to say just write out the numbers real quick and circle what you want so you know exactly what number to put here, okay? If it said greater than 3, what I want is, what I want is 4, 5, 6, 7, 8. Those are the numbers that are greater than 3, okay? So what I put in the calculator is less than or equal to 3, and then I do 1 minus, and it finds the other side. Does that make sense? A little bit? Kind of, not really? You're quiet today. 6 or more, I want 6, 7, or 8, okay? I want 6, 7, or 8. So what I put in the calculator is 5, and that finds all the way to the left. I put a 5, and then I do 1 minus, and it flips to the other side.
So you do a minus when you're trying to find...
I do a 1 minus. There's 2 different ways to think about it. I do a 1 minus when I'm trying to flip this sign. So I'm supposed to be finding greater than and I want less than. Okay? I'm supposed to be finding more, and I'm trying to flip that sign. So if I can't flip the sign, so the way you flip the sign is you do 1 minus. Okay? If you write it out like this, you do 1 minus when you're trying to find the right side. Okay? Anytime I'm trying to find the right side, which is more, I got to do 1 minus. So if you write it out like that, when you're trying to find the right side, you do 1 minus. But the way to probably think about that correctly is to say you cannot flip the sign in the Alex calculator. So in order to mimic flipping the sign, you do 1 minus, and that finds the other side. You find to the left, and then you do 1 minus to find to the right. Okay?